Okay, so today we're going to talk computation with scientific notation. So we're going to be adding and subtracting, multiplying and dividing. Today we're going to focus on multiplying and dividing on day 1. Day 2 is going to be the adding and subtracting. So if we put our names on here and the dates, we're going to split this up into day 1 and day 2. So I'm going to go through both in the same video though. So scientific notation. We have just a refresher here that we have a coefficient. This is standard where there's a number, dot number, times a base of 10 to an exponent. So scientific notation. So multiplying and dividing with scientific notation works really slick. You get to use the same rules that we have been using. The product of powers where you add exponents, or the quotient of powers where we subtract exponents. So we get to use those same rules, and the same rules for coefficients is we multiply coefficients or we divide the coefficients. We just have to make sure our final answer is in proper scientific notation. So if we go back to slide 3 or go down to slide 3, practicing some proper scientific notation. So they're saying here, since this is not in proper scientific notation, we're going to move the decimal one place to the left and add 1 to the exponent. So left helps them get larger. So we would move that from 11.52 times 10 to the 7th. One spot to the left, we get 1.152 times 10 to the 8th. Left makes it larger because, let me see if I'm going to prove that later. Looks like I'm not. But just as a refresher, if we were to write this number out, it would be, like let's say it's 11.52 times 10 to the 7th. That would move it 7 spots here. So it would be 11.52 and then 5 zeros. Well, if I needed to move the decimal from here to here, now I have to go 8 spots, and that's why moving it to the left makes it larger. So therefore, left larger, right is going to do the opposite. It's going to make it smaller. So this one we need to go 1 spot to the left. It was times 10 to the second, so it will become 1.283 times 10 to the left larger, third. We need to move this one 2 spots, 1.7982, remembering to write all of it, add 2 to the exponent of 5 to get 7th since we moved it 2 spots. This one we need to move to the right, so our exponent is going to get smaller. Now this is a negative 3. Now to get smaller, when we're talking about negatives, that becomes more negative, so 10 to the negative 4. This one we move 2 spots to the right. That is negative 9. So 2 spots smaller is actually negative 11. Okay, so moving on to actually computing with scientific notation. We have 2 coefficients and 2 exponents. So this is really nice. You're going to need your calculator. But all we have to do is we have to multiply the coefficients like normal. And then I should probably use a dot here. That'd be better, or parentheses. And then what we do is we add our exponents just like we've been doing. So if we take out our calculator and we multiply the right numbers, 11.52 times 10 to the 7th. Is that in proper scientific notation? The answer is no, because it needs to be between the first 2 numbers. So we're going to change this to 1.152. We moved it to the left. Exponent gets larger. All done. Letter A, we're going to multiply our 2 coefficients, 8.4 times 2.5. Bring down our multiplication of times 10 base. I'm going to add those exponents. 21. However, still not proper scientific notation. Decimal is here because it's always at the back. Left larger, increase my exponent. Same thing here. Multiply. Now remember, if you can't remember these rules, just rewrite these in standard form and multiply them. You could do that. Oh my goodness, this lead. 4 plus negative 3. So 2.63 times 1.2. 3.156, that's nice. It's already in standard scientific notation. times 10 to the negative 4 plus 4 plus negative 3 is 1. Or you could write it as just times 10, which would be 31.56. Kind of a silly problem to do with scientific notation. Okay, we're going to practice dividing. Same thing though. We divide our coefficients and subtract our exponents. So 7.8 divided by 1.2 is 6.5 times 10 to the 3 times negative, or 3 minus 4 is negative 1. Letter E, 8.1, oh my gosh, divided by 9 times 10 to the negative 2 minus 2. 0.9, not proper scientific notation, times 10 to the negative 4. We need to move it to the right. Right makes it get smaller. Smaller than negative 4 is negative 5. All right, a couple word problems to practice, and then we are done with day 1. So in 2010, the world population was that big number. Rewritten scientific notation is 3, 6, 7, 8, 9. The population of the U.S. was about that. About how many times larger is the world population than the population of the U.S.? So since they're asking it like that, that tells me it's division. So keeping both in standard or scientific notation, or if you wanted to change them both to proper or standard form, you could do that too. But I'm going to go ahead and divide my coefficients and subtract my exponents. It says about, so we'll round this to 2.3 times 10 to the, 9 minus 8 is 1, which would really move this over 1, about 23 times larger. I would take either answer here, but this one makes more sense in word problems. So this question asks the exact same thing. Lake Superior, the surface area of Lake Superior is the largest lake is here. Smallest lake is here. About how many times as great as the area covered by Lake Superior than Lake Ontario. So this is another division problem. In scientific notation, this would be 1.816 times 10 to the 4, which these would simplify because they're the same. So 8 divided by 1.8. So it's about 4. So it says about. So about 4 times as great. Okay, and that wraps it up for day 1. I'm going to continue as if I'm going on to day 2, but this was a day 1 worksheet. Adding and subtracting, this is day 2. Okay, so when adding or subtracting decimals in standard form, it is necessary to line up the place values. In scientific notation, the place value is represented by the exponents, so that means the exponents have to be the same. Before adding or subtracting, both numbers must be expressed in the same form. Now this looks a little bit different than your notes, but it's the same concept. Moving the decimal to the left makes the exponent larger. Moving the decimal to the right makes it smaller. Why is that true? Well, we kind of talked about this in the day 1. Here's in standard or scientific notation, sort of, but here it is in scientific notation, standard notation. Move it 5 spots, give me standard form. But if I had moved it 1 spot to the left, that's 3, 6, I needed to get left larger. But if I wanted to stop here, it was only times 10 to the 4th, right smaller. So again, just proving what it does. So the idea with these is that we just have to make the exponents match. You can either make them both the larger exponent or both the smaller exponent. You'll kind of figure out which one you think is more efficient. But I'm going to go ahead and change this to a 10 to the 5th, which means I need to make it larger, so left larger. So this becomes 0.689 times 10 to the 5th plus 9.24 times 10 to the 5th. What we can do, since these match, is just add them. So 0.689 plus 9.24 is 9.929 times 10 to the 5th, since we changed them both to the 5th. So this one's not in scientific notation, so we can just make it match this. We're going to make it at the 8th, so this would be 3, 6, 7, 8. So 0.1161 times 10 to the 8th. So I just moved this so that it would match to be 8. And this is 7.83 minus that, minus 0.1161. There we go. 7.7139 times 10 to the 8th, keeping the same base and exponent. Moving here, when they give me standard notation, I'm either going to change this to standard notation and add them together, which would be move this, 6 spots to the right, and then add them and then change it back to scientific notation, or just make this one b times 10 to the 6th. Here with 3 spots, 6 spots. So this is 0.593 plus 7.89 times 10 to the 6th. Now I can add them. .483 times 10 to the keep the same base and exponent. There we go. This one, we can try changing it to the smaller one. So if I want to change it to the 3rd, if I want to get smaller, I move it to the right. So it's 8.41 plus 97.1. They'll both be times 10 to the 3rd at this point. Adding them together, 105.51 times 10 to the 3rd, not in proper scientific notation. 2 spots to the left makes the exponent larger. Now I'm done. Maybe if I had moved to the larger one, I wouldn't have had to move it here. Who knows? I know. All right, letter E. Because I know that moving it to the larger one means I don't have to move it at the end, I'm going to move this times 10 to the 7th to a times 10 to the 9th. So I want it times 10 to the 9th. Left larger. 1.263, bring that down, minus, and the new number would be 0.01525. And the base is now times 10 to the 9th, the larger one. Now I get to subtract them. And we have this really ugly number. It's long. And keep the same base and exponent. Okay, one more with standard notation. I'm going to make it be the 5th. Actually, this is 6th. So this is 2.7 times 10 to the 6th. I'm going to make this times 10 to the 6th. Left larger. 0.63 plus 2.7 times 10 to the 6th, adding, it's me 3 point something. I'm not very good with decimals. 3.33. And we're all done. No Alex topics. Random fact, odontophobia is the fear of teeth. Have a great day.